Hello everyone, this is the Design and Manufacturing Project 1 and we'll be talking about hip replacement. Let's first briefly talk about what the video is about with a table of contents. Starting off with introduction, we'll explain what hip is and how and when it is used for. Then move on to talk about some common hip problems that people experience, then talk about the main solution to those problems, which is hip replacement. We'll define the product, discuss the design and manufacturing process of the product, present our CAD model, and finally end the video with the summary along with citations and references. So what is hip? Hip is the region on each side of the body where the thigh bone, as known as femur, joins the pelvis, forming a ball and socket joint that allows movements in various directions. On the right is a picture of hip with different parts labeled. As you can see, pelvis with acetabulum is connected to femur, which contains femoral head, articular cartilage, greater trochanter, and femoral neck. Then you might be wondering, why is hip so important? Like, how is it used? Well, to emphasize the importance of hip in our body, these are some daily tasks that use hip. Hip is used when we're going up the stairs, when we're picking something up from the ground, when we're walking, or when we're just standing up. Now let's talk about some roles and movements of hip. Some of the roles include providing stability and support, providing mobility, controlling our weight, absorbing shock, providing balance, distributing force, and controlling our posture. And the most common movements of hip are flexion, extension, abduction, adduction, and rotation. To make it easier to understand, I went over to Stone Summit Midtown to create a video showing different hip movements. As you can see here, I'm extending my right leg to the front to get my foot up to a foothold, causing flexion in my hip. Here, I'm extending my left leg back to get my foot on the ground, causing extension in my hip. During this impressive move, I'm extending my right leg to reach the foothold on the right, while facing my knee and toes forward, causing abduction in my hip. You can see here, I'm moving my right leg across my left leg and putting the foot on the foothold placed on the left side of my body while keeping my knee and toes towards the front, causing adduction in my hip. Lastly, as I set my left foot on the black block, I turn my knee and foot to the left to gain more stability. This move causes rotation.
Some common hip problems include osteoarthritis, rheumatoid arthritis, and traumatic arthritis. In affected individuals, sometimes they'll have destroyed cartilage, narrowed joint space, or bone spurs. To remedy some of these issues, people will undergo a hip replacement. So what is a hip replacement? It's an artificial device used to replace the hip joint due to hip degeneration. It can reduce pain, improve function, and over 450,000 hip replacements are produced in the US each year. 90% to 95% of implants remain viable for 10 years after surgery, while only 80% to 85% remain after 20 years. In a total hip replacement, also called total hip arthroplasty, damaged bone and cartilage gets replaced with artificial components. It's a major surgery that is very safe, but it also can include risk of blood clots, hip dislocation, and infection. This makes it crucial for engineers to create products that are safe and biocompatible for the user.
A common method for displaying the functionality of a part or system is through 3D printing. Each part of the hip replacement procedure was designed using CAD, and shown in the picture. The femoral stem provides support for the femoral head, or the ball of the hip joint. The femoral head sits on top of the stem and allows for smooth movement and rotation of the hip joint. To allow for the ball to rotate while staying in place, the acetabular cup is used. A plastic liner is placed between the ball and cup to reduce friction between the parts. After precise manufacturing of each component, the hip replacement procedure can begin. The femoral stem, femoral head, plastic liner, and acetabular cup are cleaned to prevent any infection. Even though there are only 4 components, each plays a crucial role in assembly to return the patient's hip function.
Now I'll talk about design for X. First is design for biocompatibility. There are many aspects to consider when we design products, and for hip replacement, one of the most important parts to consider is its biocompatibility. The compatibility with living tissue or a living system is necessary as it will be replacing joints directly connected with bones and muscles. The creative design assures that the product possesses minimal toxicity and physiological immunological reactivity. The femoral head and acetabular cup are typically made out of cobalt chromium, titanium, or ceramic as they have minimal reactivity. Also, improvements in implant design, as shown below, and surgical techniques reduce the risk of revision surgery. Next is design for manufacturing. The femoral head and acetabular cup are usually shaped by forging or investment casting, followed by rough machining, polishing, and coating. Ceramic biomaterial elements, such as alumina and zirconia femoral bowls, are normally produced by sintering, followed by grinding and polishing and lapping. The polishing and lapping should be integrated with a CNC process of which the control relies, to a great extent, on a uniform material removal over the whole area to polish. This video demonstrates the CNC process. Now we create femoral head. We create femoral head by 3 turns. Now we create a acetabular cup. We create the cup using echo cut and ribbon. Next is design for assembly. The damaged cartilage is removed and replaced with a metal socket. Screws or cement are sometimes used to hold the socket in place. A plastic, ceramic, or metal spacer is inserted between the new ball and the socket to allow for a smooth gliding surface. The bearing surfaces of the ball and socket needs to have a high grade of surface finish and to maintain a high engagement stability of bearing when a patient takes different kinds of motion.
The patient is put under anesthesia to remain pain-free during the procedure. An incision is made along either the front or side of the hip, and the layers of muscle are pushed away to expose the hip joint. The surgeon then dislocates the femur, and assembly begins. First, the acetabular cup is prepared by securely fixing it into the pelvis bone using medical-grade cement or press-fit techniques. This ensures a stable foundation. Next, a plastic liner is placed in the socket to reduce friction, enhancing the longevity and functionality of the hip replacement. Lastly, the femoral head is attached to the stem and is carefully inserted into the femur bone to replicate the natural hip joint's spherical movement. Special care is taken to ensure optimal alignment and positioning of both components to restore the hip joint's range of motion and stability. The surrounding tissues and muscles are carefully sutured back into place, and the surgery is complete. Throughout the assembly process, precision, attention to detail, and adherence to strict surgical protocols are paramount to restoring mobility for the patient.